Hello everyone, I'm Xiaogan. Okay, in this lesson, we will mainly refine the structure of our loop. What we are writing now is actually the outer loop. The outer loop is the coarse grain process of this engine, and here is the loading coarse grain process, followed by the engine loop and the end of this engine loop. Now, our inner loop is the work we need to do ourselves. So we need to write our own coarse grain code here and our destructor code here. Then put a loop content here. Then let's first take a look here. Roughly what the frame rate is for each loop. First, we get this platform time. First, we start here. At this point, we record this. Latest time, last time. Then next, we record the time when we start. At this moment, then our data time equals our current start minus this previous time. Then after all the code has been executed, we update the time we used last time. Right, okay, so we need to print how much time we have currently used. How do we print it? So we calculate it here. We can just print it directly here. We call it data in. Why didn't we use this? Because you will find that this thing, it is actually a fixed value, not our real tick value. So we did not use this data time. Then we are here. Let me show you. We should log here. Here, we give an F. Then we are at this place. We are at this place. Oh, this data time here. Now it forces a sleep of 0.01 seconds. Let's take a look. Then you will find that our current frame rate is probably around 100 frames because we forced a sleep of 0.01 seconds. So it fluctuates around the frame rate of 100 frames. Then what we need to do now is to comment out the sense. Let's take another look. Then you will see that this has become very small. So what is the approximate frame rate? Then we can just invert it here. This data, let's call it frame rate. Let's call it FPS. FPS. Then we divide 1 by it. Let's take a look now. This seems to be written incorrectly. It would be more appropriate to use %d here. Okay, then you will see that our current frame rate is roughly around 1 or 2, somewhere between 1000 and 2000 frames. This frame rate is pretty good, right? Actually, we can take a look. If we don't bring these things, what is our frame rate? Then we write it into our blank. Inside this. For example, if we don't bring this frame rate now, we find our say inside this. We let it do a while loop. And for this loop, we give it a, or we can just write it like this. We can take a look. Wait a moment, let me find out. Slate where code here. Then we write this part the same way. As for the instructions, we might need to. Let's define it. And this part needs to jump back and forth. This part checks if there is an exit. If the engine has exited, we exit. Then we should need all of these. We need all of them, but we don't need the Slate stuff. Okay, then the work we need to do at this point is to copy the code from here. And there is a time calculation here. Put it here. Then we put this here. Okay, here, let's change the zhi character. Now let's launch this project. Pay attention to our zhi character. Let's take a look at the current Blink project. What is its frame rate approximately? There are breakpoints here. Let's remove the breakpoints. You can see our frame rate. It's around 10,000 frames per second. That is 10,000 frames. Notice the bottom right corner. The previous one was running too fast. It's around 8,000 to 10,000 frames per second, but sometimes the frame rate is high. Sometimes the quality is low. But actually, we don't need to design it this way, because when we write it normally, we won't need such a high level of design. Let's log a date in a moment. Write a log. Let's go back to this place. Okay, actually, after we handle this, we'll comment this out, because we don't really need to turn on this log. We can actually use a macro here. For example, let's define a macro to enable this detection time. Then we can make it output a log, or not output a log. That is possible. Let's brush this frame rate here. Limit it to this 0.01. Let us develop normally. We won't write it like this, because if you have many tasks here, then you will have 0.01 each time. Then we will determine, that is, this segment of tasks, if completed within 0.01 seconds. Then we let it sleep for a difference. If it exceeds 0.01 seconds, then we won't let it sleep. Actually, there is a lot of this code here. Right here. There is also code like this. That is, in this place, we should have 0.01. Yes, if we exceed 0.01, we let it sleep this much. If it does not exceed, we will not let it sleep. When we sleep, it is better to put the time on top. Let's check the date. We haven't set this date here. We can release the date. This calculates our actual time. Let's put it below. We only calculate the entire time. That is a judgment after we add this 0.01. Just take the maximum value, because after this value is subtracted, it may exceed our desired time. You see, at this point, it can basically stabilize at around 100 frames. There is no problem. Okay. Actually, there is another piece of code here. That should also be this code to go to this, to go to this garbage technology thing. You wash it to this place. Then this place also has our time. We can give a time like this. Yeah, let's put this time up above. Put it here. For this time, we consider giving it 0.01 seconds. Here, we write it as 0.01 seconds. Okay, let's take a look like this. See if it can meet our needs for this small program. We want it to have a working frequency of 100 frames. Okay, actually we can put this part up above. This way we can see its actual operating status. Okay, good. That should be fine now. Roughly writing it this way. We control its frame rate to around 100 FPS. We also perform some garbage collection related work. Good. What do we do next? We will cover these few lessons first. This part mainly adds a frame rate monitor for everyone, and you know our Blink project. Its frame rate is extremely high, about 10,000 FPS. But after we add Slate, actually our frame rate is only around close to 1000 FPS. You can comment these out. Comment out this Slate. This code should be placed in the middle. It should be placed before the sleep. Yes, after putting on the Slate, we will probably only have about 1000 frames in this situation. We should put this time here. Put it here. Okay. We will stop here for this lesson.